We have 15 participants, 16. Okay, let it. We have 15 participants, 16. Okay, let it. সুজিত তুই খেলা একটু চেয়ারম্যান জন করলে একটু বলো।
ওকে,
আমি দেখছি প্যানেলিস্ট 5 জনই আমরাই আছি এখানে, আর কেউ নেই।
না।
আর বাকি ভিভিআইপি রা মনে হচ্ছে না কেউ আসবেন। So we have 15 participants, 16. Okay, প্রেসিডেন্ট সাহেব তো নরমালি জয়েন করেন না, তো সন্দীপ নেই নিশ্চয়ই। আর
বলবো,
আমি দেখছি প্যানেলিস্ট 5 জনই আমরাই আছি এখানে, আর কেউ নেই।
না।
আর বাকি ভিভিআইপি রা মনে হচ্ছে না কেউ আসবেন। নরমালি জয়েন করেন না, সন্দীপ নেই নিশ্চয়ই।
Hello.
হ্যাঁ, আমাদের চেয়ারম্যান সাহেব জয়েন করে গেছেন।
Am I audible?
Yes sir, we can hear you.
Mr. Chakraborty.
হ্যাঁ বলুন।
Actually আমি কিন্তু রাস্তায় গাড়ির মধ্যে আছি, তো আমি ভিডিওটা অন করছি না।
হ্যাঁ ঠিক আছে, নো ইস্যু। Then just let me start then, right? Dr. Das, আমরা শুরু করি।
হ্যাঁ, একটু স্টার্ট। হ্যাঁ,
just start.
Good afternoon. We are starting our webinar this afternoon, Robotics in Agriculture. I now request our chairman, West Bengal State Center IEI, to give his welcome address. Dr. Das, please.
Good afternoon, everybody. Most welcome to all the participants. Mr. Ramchandra Chakraborty, Joint Convener, Honorary Secretary, Mr. Chanchal Chakraborty, the moderator, and today's eminent speaker from CDAC. Actually, right now I am on the road. I'm afraid I will not be able to take much of your time, but it is my pleasure that the Electronics Engineering Division of West Bengal State Center has organized this webinar on very, very interesting and current topics, latest topics, robotics in agriculture. Today, as you know, agriculture is the prime, I would say the prime industry in India. So since beginning, we are depending on agriculture, and today also most of the parts of the country are depending on agriculture and the outcomes. And if we can apply the robotics on these agriculture areas and etc. instruments and process basically, and AI and other issues, then I believe this agriculture, the production and other benefits will be getting more and more. And so basically our India is agro-based industries will be benefited more with this robotics concept, application of robotics and in artificial intelligence in the field of agriculture. So I believe today our lecture and webinar lecture will be much more interesting and effective. And I welcome the eminent speakers from the CDAC. In fact, I had a relationship with CDAC. In fact, I visited many times to CDAC, and I believe the most knowledgeable persons are available in CDAC. I hope today's lecture you'll be enjoying, and the webinar will be having a great success to all the participants. Thank you very much. Please go ahead.
Thank you very much, Mr. Chairman, for your welcome address. Robotics in agriculture. This talk presents the design and development of an autonomous, multi-purpose agricultural robotic platform, primarily for paddy cultivation, developed at our CDAC research lab. The mobile robot can navigate in paddy fields so as to ease out the life of farmer, particularly in a situation when the availability of agricultural labor is scarce. Precise monitoring of the health of paddy in outdoor fields is of utmost importance for the optimum usage of irrigational resources. The application of fertilizers and pesticides in controlled amounts and at proper times. This comes under the purview of interdisciplinary cyber physical systems and IoT, wherein there is an abundant use of machine learning, data analytics, image and signal processing. The research also extends into the very promising, challenging task of agriculture, harvesting with two special cases, vision-guided, AI-enabled apple harvester targeted for Kashmir, and selective tea to leaves and a bird plucking for northeastern tea plantation. Use cases of robotic platform for paddy cultivation, apple harvester, and tea pluckers will be discussed. It's a very, very interesting topic indeed. Sudhir, do you expect anybody, Mr. Mundada or President or Sandeep? Sudhir?
I don't think anybody is
So should
going
I
to
go
come.
ahead and
Yes,
introduce the panelists?
Yes. So better introduce the panelists and let them start.
And they can start. So
yes.
Yeah.
our first panelist, Dr. Hina Rai. Sudhir, কিছু বলছো?
Vishamji, you can introduce the moderator and then moderator also can take over the list.
সুদীপ, আমি প্যানেলিস্ট আর মডারেটর তিনজনকে ইন্ট্রোডিউস করে দিচ্ছি। Okay. Our first panelist, Dr. Hina Rai. She is Joint Director at Center for Development of Advanced Computing, Kolkata, CDAC, Kolkata. She is the Joint Director at the Center of Development of Advanced Computing, Kolkata, an research and development organization under the Ministry of Electronics and Information Technology. She is also the adjunct professor, IIT Dhanbad. And Dr. Hina Rai has completed her PhD from Instrumentation Electronics Department, Jadavpur University. She has 25 years of research experience in system designing, process automation, image processing, artificial intelligence, Internet of Things, robotics, sensors, and sensing systems. She has 5 granted patents, over 25 research publications in leading international journals and conferences, and has several accolades to her name. For instance, being champions in Intel Embedded Challenge 2011, winning the Best Paper Award in IEEE BHTC Conference 2020. She has led her research group for multiple Government of India funded projects, and most of them gone through transfer of technology and now in use commercially. Thanks, ma'am, for your time to the webinar this afternoon. We have second panelist, Mr. Soumik Laik. He is Knowledge Associate with CDAC, Kolkata. He is an engineering graduate from Jadavpur University and MTech from the NIT Trichy. Currently, he is working as knowledge associate in CDAC. He has developed an autonomous navigation algorithm for the project Samadhan. He is working on image processing based tea leaves detection and identification for the project titled Tulip. He is developing a communication protocol stack using Bluetooth low energy for continuous data. He is also involved in collection of cattle for the project Cattle Health Monitoring System. Thanks, Soumik, for your time for the webinar this afternoon. We have our moderator, the convener, EG Division Subcommittee West Station IEI, our dear Chanchal. He is BE MBA, has more than 35 years of professional experience in telecom and IT, worked with flagship companies like CESC, NTPC, and Department of Telecom, GSNL, and worked as Chief Technology Officer and Vice President in Aircel, Uninor, and Reliance Jio. And that means he is seen from the birth and growth of telecommunication in India. He has wide experience in planning, design, procurement, installation, and maintenance in all fields of telecom. Currently, he is working as CEO of Atmi Private Limited. He has participated in several national international seminars, including GSM Congress at Cannes, France, and Berg for international roaming. He has received different accolades, including the Vishish Sanchar Seva Award from the Ministry of Communication, professionally associated with IEI India and ISA USA, a team player and loves to serve society to the best of his ability. Now we hand over to Chanchal to moderate the session.
Thank you, Ramda. Now I will invite Dr. Hena Ray and Somik Lai to have the today's give the presentation. So Dr. Ray, now the platform is yours. Thank you very much.
Thank you all, and good afternoon and namaskar to one and all. Happy Eid and happy Akshaya Tritiya. Shomi, kindly share the screen, please. Thank you, Shomi, and thank you all. Now, today's presentation is all about robotics in agriculture, and our session is divided into two parts. First part will be covered in the term of agricultural robot, and will be covered by myself. And the second session will be covered by my colleague, Mr. Shomik Lai, and his topic is basics of robots and robotics and implementation for agriculture. Both of us are from CDAC, Kolkata. CDAC, that Center for Development of Advanced Computing, that's a premier R&D organization under Ministry of Electronics and Information Technology. And we are born in the year of 1988 with the mission of creation of supercomputing infrastructure in India, when United States of America denied to support India to use the high-end computing infrastructure at India. And we have 12 centers across the length and breadth of our country. CDAC Kolkata is one of them, and our center is having 4 distinct research groups, mainly agri and environmental electronics, information communication and security awareness, advanced signal processing, software technology, and apart from the administration, finance, and quality. Our group, where we belong, that myself and Mr. Shomik, they are dedicated for development of sensor and sensing systems and solutions, image processing, and biosensor related products. Most of our solutions related to agri and environment, and few case studies are there for the healthcare domains. And we are specialized on embedded electronics, IoT, and robotics. Without taking much introduction of our center, I request Shomik just to go to the next slide. Yes, thank you. So in the slide and in the introductory session, what we have seen that the proliferation of robotics in India, that is very much essential. Even if we think then the industrial sector also, that the robotics application is very, very less. What is the reason behind that? The reason is the main prohibitive factor is the cost. The agriculture sector cannot even think of using the robots in the field, but agricultural robotics and allied technology is definitely the need of future. And it has to come today or tomorrow in India. Now this is the time we have to prepare ourselves from all angles, like technology readiness, like the social and farmers education and policy. Also, it is a need of the hour for the investment in the appropriate agricultural innovations in India. Now, from the slide itself, what we have found that the challenges in Indian agriculture. If you see in the first picture, where we have seen that the population explosion across the globe and in India in particular. If we see that the spaces which are being laid in the Indian motherland, that is overcrowded by population. So all the people need food. So we all depend on agriculture. But there is a scarcity of land, there's a scarcity of people, because we know all the young generations, they are slightly migrated from that agriculture to the different service sector because of the low incomes and all. Parallelly, if we see that the right side picture of climate change, that's a very, very alarming factor and global warming also take a lead of this thing. Because we have seen today also there is a very unpredictable weather condition like heat waves, more cooler winter, abnormal rainy season, and high occurrences of cyclones. And this not only creates a problem to the human beings, but these heat waves cause a extreme heat stress in crops, which can cause a yield loss if we not encounter the proper irrigation. And it will encourage also the weed and pest proliferation. So pest management becomes a very important nowadays, and higher amount of weedicide and pesticides incorporation is also need to be controlled. And parallelly, that with the heat waves, there is a heavy rain sometimes occur that causes the flood, and that is the detrimental to crops and soil structure. So what it happens? It reduces the production of food by 50% because that the growth of population as well as the yield production that is very low. And then what is the result of it? There is an income of farmers is getting reduced. And parallelly, that the young professionals, those who are coming from the farmer community, they are not into the field, they are coming to different service sector. Then why we are coming to this topic? Because technology readiness level is the need of the hour. Without this, we cannot get rid of this problem. Next slide. Keeping in mind of all the features, all the requirement, we have come up with a solution that is called agricultural robot. Generally, we feel that the robot is looking like a human being and it will move like a Sophia that behaves like a human being. But the robot doesn't mean that it should look like a human being, but it will just replace the human repetitive works. What are the people are doing in a repetitive task that is being assisted by a robot, that is being assisted by a machine. So what is the objective of this particular thing? Particular thing is that we are going to develop an autonomous robot. Why autonomous? So there is no need of human intervention. People are not required into the field because in the last slide what we have seen, there is a scarcity of land, there is a scarcity of experienced manpower, and young people are not into the field. So we thought now it is the time we have to prepare ourselves for the future generation. And we have developed an autonomous field robot. And this robot is like a vehicle. And in the picture we have seen that the vehicle is having 4 wheels. And this vehicle can traverse the entire paddy field without the human requirement. And there is another important challenge in Indian agriculture is that the land are very limited and it is a very small in space. So moving the vehicle in a very small space, it is a very big challenge. It is not a country like America, it is not a country like Germany and other places where the land is very big and things. So there is a movement of vehicle is not a big challenge. But in India, that the space that the agricultural land are very segmented and very small. So while the vehicle is moving into a very small space, and the development of technology to move into that particular field is a very challenging task. Keeping in mind of all this Indian agricultural scenario, what we have designed a robot. It is a vehicle, 4-wheeled vehicle, and this is operated fully by battery. And it can either operate through remote like a joystick, or it can move into the field through a program giving into the robot. So what are the functions of the robot? This robot is basically do the replacement of a human farmer, and it can do the entire farming operation except the harvesting. It cannot do the harvesting because we feel there are a lot many instruments are available in India which can take care of the harvesting and sorting of paddy and all. So it can operate from the 0 days of farming. It can operate up to the 55 days of operation before the harvesting. So first thing is that it will show the seeds. It will show that seeds, and so there is an attachment that is called the drum seeder, and that will show the seeds in a regular interval of time. That process is called the DSR, the direct showing of seeds. And there is a technique that is basically available in Indian agriculture that's called the transplanting. After showing the seeds, they will put that the small germinated plant onto the field over a regular period of time or in a particular fashion. But here the system is that because of the research of different ICR, Indian Agricultural Council and research, they have shown that if we go for the DSR instead of the transplanting, the productivity will be more. So we have followed that the same methodology. So it first do the showing of seeds at a regular interval of space. After that, from the second day of operation, it will go to the field just to have a scouting of entire field, whether there is any weed or not. If they found some weed are there, they will spray the weedicide. It will spray the weedicide. How does it do that? I'm coming to the next slide. Basically, that will take the technology of artificial intelligence and computer vision. And when the germination started, mainly 4 to 5, after 4 to 5 days, there is a small paddy plant grows into the field. Then it start doing the monitoring of health of crop. Basically, what it does, it takes care of the chlorophyll index of the plants germinated from seeds. And how does it take? Because it will take care of the entire leaf color using the color chart that is available with the agronomist of agricultural community. And apart from that, the chlorophyll content estimation, it will see that the seedling count, how much seeds are getting germinated, that is also taken care by the system. And growth monitoring, and that growth monitoring is basically, it will take care using some sensors that is called the LRF, that the laser range finder, to take the distance from the ground. And tillering mounting, that is how much branches are there, how healthy the tree is. If it is not, so based on that, the AI algorithm that is put into the system, it will spray the controlled amount of fertilizer based on the need of the field. And final thing is that when the tree are small, in matured enough, like the 20-25 days of operation, what it does, it will take care of the health of the leaves and stems, and it will check that whether there is any pest attack or not. If it will get any information about that fungal infection, then it will spray the pesticides, but it will not spray the pesticides in the entire form. What is the main problem in nowadays in agricultural community? They used to do the periodical spraying of pesticides, periodical spraying of fertilizer, and that doesn't cause the harm to the farmer health only, but it will detrimental for the crops and leaves also. And parallelly, it will wastage of the chemicals. Just to take care of all the issues, we are just spraying the controlled amount of chemicals onto the field based on the need. And that we have done. We have a long image corpus that information it can do that the controlled spraying of pesticides as well as the fertilizer, and it will do the spraying of weedicide and pesticide also. Next slide. Now coming to the point of the challenges. I told that the Indian agriculture is very small and fragmented. So running the vehicle into the field and also running the vehicle up to 55 days operation when the crop height is like a human height, almost small baby's height, so almost 2 feet and 1 feet height. So that the ground clearance is a very important thing. if we talk about the mechanical design of the particular vehicle, that the stability and the CG of the vehicle is very important, because the vehicle ground clearance is almost more than 2 feet. Generally, the vehicle is not so big and so that doesn't have that much of ground clearance. But our vehicle, what we have developed, that is particularly meant for the paddy cultivation, which can operate into the field up to 55 days of operation. So what we have done, we have made a sufficient ground clearance of the vehicle so that it can maneuver into the field without damaging the crop and paddy plant. And second important technology, which is the USP of our product, that is the precise navigation. If we see in the right side, the picture of the paddy, that all the paddies are separated, they are having a separation of 15 centimeter, and the two rows are separated by 20 centimeter. Just have a look of the 20 centimeter gap of the two paddy plants, and running the vehicle of a particular wheel, it is a very challenging. So we have developed the vehicle in such a way that the wheel width is very small, only 6 centimeter, but our gap is 20 centimeter. So our navigation should be so proper and accurate, and heading accuracy is such that it should not put onto its wheel onto the leaves or crops. So that the precise navigation of 20 to 30 millimeter, only 2 to 3 centimeter accuracy we have achieved, and heading accuracy, that the movement, that the direction of the vehicle, we have only 1 to 2 degrees. So we are taking care of the 20 centimeter gap while it is moving onto the field without human presence. And another important thing is that the real-time decision and actuation. While the vehicle is onto the field, it will take the image using the camera, and immediately it will take the action. So sensing and actuation, both the things we did in the real time. And the vehicle is able to move in the muddy water field farmland. Now, although this is not fully correct, because now it can move only the dry agricultural field. So we are working on it so that it can maneuver that the strain, that the torque getting from the muddy and waterlogged field. And it can operate at a stretch 4 hours. So the battery is such that it can work 4 hours. After working, we need to give the charge to the battery. It's a rechargeable battery. So after the next form or next land, it can work at a stretch of 4 hours after giving the charge. And while it is moving into the field, nowadays how the farmers are giving, putting their like this, that will go from the one point to another point, then right, then back. Like that way, it will move into the field. And this pattern is called the ox pattern. Next slide. And what are the things it will do? I already told that it will do the weed control. Weed control is basically when there is no germination, it will take whether there is any green pattern or not. If there is any green plants and all, it will not remove it. It just spray the it will just spray the chemicals to destroy it. Then chlorophyll index. In the right side, we have seen there is a chlorophyll chart. And in the chlorophyll chart, there is a scale, that 1 to 6, and based on that image matching algorithm, we will see what level the chlorophyll is. If it is a properly nitrogen efficient or nitrogen nutritious leaves, then it will not spray any chemicals. But if there is a deviation, then controlled spraying of fertilizer is being done. And then it will take care of the plant growth, seedling count, tillering, and disease detection. We have a very good image corpus of different fungal disease, and whenever that we have taken from the Vish Agricultural University Ranchi, they are one of our partner, and now the vehicle is also in trial in the field itself. And this disease detection is basically an AI/ML based algorithm, and rest of the image processing we are doing the image processing based application. Next slide. Here we will get that the architecture of the electronics and communication. If we see that the brown box, that is the main intelligence unit, that is called the master controller. And why we have taken that the GPU board and all, I told one of the most important parameter of the vehicle is the real-time sensing and real-time actuation. And without the GPU computation, without high performance computing, without the AI ML algorithm, we cannot do in the real time. Then we have to do entire thing in the offline. But our vehicle will not do the same thing. It will take care of the plant health in real time and do the proper measure at the real time only. Show that the entire architecture is on the GPU computing infrastructure. Herein we are using a Jetson TX2 board, and Jetson TX2 board is another important feature is that it is a CAN controller is there. So you know all the vehicle is a CAN enabled network. So it will work in the noisy environment. So GPU is our main controller, and all the sensors and actuators and cameras, they are connected with the I/O pin of the GPU. And the left-hand side, this is called the graphical user interface, and the farm manager or any agriculturist who want to operate the vehicle from remote person, so they can operate it through the dashboard. This is a dashboard that is being used by the farm manager or controller. And otherwise, what we can do, if we put the system with a programmatically, then it can maneuver the field autonomously. So this is the dashboard, and in that there is a camera, and all the cameras are connected to the main controller in a wireless mode. And this is connected in the bottom part of the vehicle. It will capture the image, and once the image is getting analyzed, and if it taken some decision, and that decision will be performed by the actuators. That is the right side of the picture. Then there is a main controller, and there is some drive. As we told that this is a 4-wheel device, and all the vehicles, all the wheels are equally drive and equally steered. And the important thing is that the vehicle is of holonomic drive. So when the vehicle is at the end of a field, so it will not getting a turn like our vehicle turn. It just slides. So that also important feature. So it will not damage the field. That will damage the crops. So that is being taken care. So now that the motor controller will drive the vehicle based on the information received from either from the dashboard or from the program that is given into it. And there is some important thing is that it is enabled with RTK sensors, and RTK GPS sensors, basically this is called the real-time kinematics. And if you go for that outdoor navigation, and this type of sensors gives you the proper information of the lat and long, as well as the heading information while it is maneuvered into the field. And RTK GPS is basically, there are two types of sensors. One is called the RTK base, and that base is in the farmland itself. And another one is the RTK rover, and that will be put onto the vehicle. And base basically getting the satellite information about its position, and whenever there is an correction factor is there, that is called the RTCA, and that will be communicated to the rover using some wireless communication. Now, even our system can able to provide this information using the Zigbee communication, and that will giving around 300 meters. But if you use the long range Wi-Fi, and the farm field is a very big, then it can cover up to 3 to 5 kilometers communication of RTCA. So we are now achieving both the things in real field. So RTK basically gives you the navigation information, like where you are positioned, like your lat and long, and also its orientation, in which direction you are in. For that, we are also using an IMU. So in the fusion mode, we are using the RTK along with the IMU that will give you the correct latitude and longitude, as well as it's the direction information. So this is the basic architecture of the vehicle. Next slide. So this is the navigation block diagram. Here the base basically receiving that the satellite from satellite, we are using the GLONASS, that 4 satellite information about the lat and long, and whenever there is a correction, that RTCM message, RTCM data will be communicated to the rover for correction of its particular lat and long, and it will take care of its own position. Next. And this is the rover. On getting the lat and long, it will communicate this information to the main controller, and based on that information, it will send the command to the motor controller, and then the wheels will be moved and the motors will take care of the movement. Next. And another important thing of the vehicle, whenever we are going for any robotics applications, we are taking care of an operating system that is called the ROS. And ROS is the robot operating system. It is not entirely operating system. It sits onto our operating system, like it is called a meta operating system. And whenever we are going to use the ROS and all, we are installing the entire thing onto the Linux platform. And Linux, basically, these ways will be taking care of all the process management, thread and all, but it will give you that the APIs and all to make your development process very easy, and development time will be also very less. And if you work in a Windows platform or in the Linux platform or Mac OS, if you have some APIs and all, you can add on all to that on the development. So it is a totally platform independent, and parallel it's a language independent also. If you work into the C, C++, Java and any other language, it can take care of all the things using that the ROS meta system. So another important thing is that why we are using that the ROS. First thing is that the development time and cost is less. But apart from that, it is a very beautiful thing is, like we know there are several sensors, several actuators. Say we are having a camera. That camera will give you the picture, and that picture will help you to detect whether the chlorophyll index is your tolerable level or not. Simultaneously, this picture will also give you the information about whether there is any pest attack or not. So if you are not using the multiple cameras, that the same camera will give you that both the information. Show me, slides is not showing.
I think Dr. Ray, I think Shomik got dropped.
But that without slide, how can I move? I'll talk Shomik. I'll talk Shomik. Just a minute.
Right.
Chanchal, you have the slides with you?
Let me see that those slides may be older one.
Oh.
Let me see. Let me see.
The give it can be helped, I think.
Let me see.
Yeah.
Shomik is joining now. Just a minute. Shomik is joining.
Okay. If there is any problem, you can tell me.
No, basically what happened, his computer got shut down.
No problem. No problem.
But sir, because of some other assignment, I'm leaving now, and Shomik will take care of the entire things. And so I'll just complete that one. And this is the robotic operation. So that the image. So if I talk about the image of the chlorophyll index estimation as well as the for the disease detection. So we should not use a multiple cameras for each and every operation. So what it will do, it basically having a multiple nodes. Let's say the 2 nodes. One node is taking care of the chlorophyll index estimation, and another node is the disease detection. But now the image is available into the camera's file. So whenever that the particular node wants to have this particular image, they are subscribed to the image, like it is called a public subscribe mode. So the image is available whichever node is getting registered with the publishers. So image will be distributed from all the nodes who are basically in need of the particular image. And so if we go for a multi-sensor and multi-actuator based information, so we always go for the robotic operating system. So now I'm leaving, and Shomik, you please take care of the entire thing. And thank you all for listening and giving me the platform to explore my work. And Shomik is working with us, and he will just deliver the rest of the things. Thank you, sir. Thank you all.
Thank you very much, ma'am.
Thank you very much, ma'am. You have come because even there is a busy schedule for you. So thanks.
No, it's okay, because I told na I'm in Bangalore, and I am in ISC Bangalore. And,
I know.
Okay, Shomik, you please take care. Bye. Okay. Bye. I'm leaving. Okay. Sorry, sorry for that.
No issue, no issue.
So good evening, everyone. So as ma'am has already told, there are various applications that the robot can handle. So if we see what is the originality of approach, and if you see that there are various kinds of, mainly there are 7 things that it accomplished. Like first one is that it is a unique robotic vehicle. So that means it is a in the Indian agriculture scenario, this is the first time that robot can handle a multi-purpose role. Means it can do the chlorophyll index, it can measure the growth of the plant, and also it can detect the disease also. So in the Indian agricultural scenario, this is the unique vehicle. And second thing is the holonomic drive. So what is a holonomic drive? So that means it can rotate itself on its origin. Means whether when it is standing in the front, it can move towards south just only by staying on the same position only. So it has 4 wheels, and the 4 wheels can rotate on their own axis. So if we move the front 2 wheels 45 degree, means right wheel to 45 degree inwards and left wheel to 45 degree outwards. Similarly for back wheels also. So what we can achieve is that we can rotate our wheel by just on its own axis only. So this is a holonomic drive. The third thing is that the plant health detection. So by estimating the chlorophyll index, what it is actually doing is that it is estimating the plant health. And if the plant is not healthy, it has the capability to spray some fertilizer on it so that the plant health increases, and as well it will increase the yield also. The next thing is that it has an autonomous navigation. Like ma'am has already told that the field itself is a little bit tricky to maneuver a robot. So we need a system which can precisely monitor its position. So for that we have used RTK-based GPS system, and this has achieved a tremendous amount of accuracy, like 10 millimeter. So with that GPS system, we have programmed our robot such a way that it can automatically move inside the field, and based on the image processing and based on the results it got from the image processing, it can do the necessary jobs like spraying of pesticides or fertilizer. Now this robot can be operated manually or by using the autonomous navigation. But when we are talking about manual operation, generally the agriculture field are a little big. So to communicate the robot from the far end, we need a long-range Wi-Fi communication. So we have incorporated that thing also for manual controlling the robot, and we have found out that from about 2 kilometers away, from 2 kilometers away also, we can command our robot to move inside that field. Now let us come to the strength and limitation of this kind of robot. So what is the strength? as I've already told that it's an autonomous navigation or remote control based operation. This is a modular software framework is there. Minimum plant and crowd range, because as this is a precise autonomous navigation can achieve, so the crop damage will be minimum. We have introduced an advanced image processing technique to accurately monitor the health. So this is also one good strength of it, and it can do the control spraying. Like ma'am has already told that when manual spraying is happening, then there are a lot of wastage, and that wastage, pesticide or fertilizer, whatever it is, may not only harm to the farmers, but also harm to the environment also. So by reducing the amount of pesticides or fertilizers required for particular plant, we are now enabled to minimize the risk to the farmers and the environment also. But what are the limitations? If you remember, if you can see the picture of the robotic vehicle, it is not designed to work in the muddy field operation, as this is a robot operating in paddy field. Most of the time the paddy field will be a muddy type, so this robot is not capable of handling this kind of muddy field. But we are now in process of modifying the wheel so that it can move inside the muddy field also. The structure wise, as is the first time means the first time of this kind of robot is has been built in the for the Indian agriculture scenario. So there are a little bit structural problem are there. And besides that, this is not a wonderful, as this is the not just structural one, good structural design. So there are some kind of what you say, some kind of mismanagement is there, and for that it is not being weatherproof or waterproof, rather I say. And this is as this is although this is a modular software framework, but for manual operation you require an skilled manpower which can operate it as accurately as possible. So this is a little bit demonstration here, working in the paddy field in British Agricultural University, Ranchi. As you can see, lower part there are 3 nozzles are there. So from these 3 nozzles, it can spray the pesticides or fertilizer as required. These are the 4 wheels, and these 4 wheels, as you can see, they are putting a lot of pressure in the ground. So that means in the muddy field, it is not able to handle its load itself, and it cannot move. So next thing that we are now currently developing is that an apple harvester. So what will be the job of this apple harvester? This apple harvester will be deployed in Kashmir. So in the Kashmiri region, because of shortage of labor and high labor cost, most of the times the apples are not plucked. And when the apples are not plucked, they are this cost a lot of money to the apple growers. So what we are trying to develop is that an automated apple harvester that will pluck the apple, but just not only pluck the apple, it will safely handle it. Like if the apple is not handled correctly, there may be some bruises happening inside the apple. So it also lowers its quality, and as the apple quality lowers, so that means the income to the apple growers also reduces. So our main scope will be here to make a human-driven or remote control vehicle that will be moving through the apple orchard. There will be an robotic arm manipulator and gripper. There will be 6 degrees of manipulator, freedom manipulator, and there will be a suction type gripper. For detecting the maturity and the location of the apple, an advanced image processing based algorithm is also currently in development stage. So what we have thought of that is that there will be a 6 degrees of freedom manipulator. This manipulator in the in the front of this manipulator, there will be a gripper or end effector, whatever it is. So this end effector will have multiple sensors. So main job of the manipulator will be to guide this gripper in the appropriate position such that it can grab the apple from the apple tree correctly. Now, apple does not means forms in just one apple. It will be a bunch of apples. So the robotic gripper has to avoid touching any other apple or any other branch. So what we have to do is that first we have to localize where is that apple is. Now to localize that apple, we are using an RGBD camera. The main features of this camera is that it can take the picture as well, but apart from taking the picture, it can also provide the depth information of also. So with this depth information, we can estimately calculate where is that apple is. Now in the gripper, there will be three sensors. One is distance sensor, position sensor, and proximity sensor. All these sensors will be used to find to guide it properly towards the detected apple without harming another apple or without damaging its own arm. Because this end effector or gripper, there will be highly costly things, and there will be much more. They can be damaged easily. So with this, using these sensors and taking the feedback from these sensors, we can pinpoint its movement towards our apple. Now to do all those things, we require a controller. So here also we were using an TX2 board or TX2 Jetson TX2 main controller, where all this information will be gathered and processed. First, then RGBD camera will provide us the picture and depth information. From this taken picture, we will be using our image processing algorithm to identify and localize where is the apple is. From this localized image, we will be calculating what will be the global coordinates of our robot, because as we are taking picture as an input, the picture will be in pixel format, means the values will be in pixel, but our robot does not understand any pixel values. It only understands coordinates like x, y, z. So the main controller job will be to transfer this pixel value to global coordinate value, and this global coordinate value will be then again fed to another program where it will calculate what will be the angle of each and every joint, so that the gripper can reach our detected apple accurately. So after gripping after taking the apple, it will be stored in a storage board such a way that it will not harm any of the apple, so that the quality of the apple remains same. So this is the whole process of development. First, we have identified that what will be the camera to be used to take the picture, and also which can provide us the depth information as accurately as possible. Then we are in kind of developing of an inverse kinematics based manipulator. Means we are developing an inverse kinematics algorithm that will precisely calculate the angle of each and every joint of the manipulator, so that the gripper can reach an exact position. This position value will be generated from our main controller by through the image processing techniques that we have developed. Now, for image processing techniques, there are multiple image processing techniques are available, like YOLO V3, FCN, and MaxNet. So currently, we are using YOLO V3 in our case. In YOLO V3, we have achieved a good amount of accuracy and precision. Using this YOLO V3 technique, we are now developing. We have taken some pictures from Kashmir apple orchards, and from using these images, we have trained our YOLO V3 algorithm, and from that YOLO V3 algorithm, we have got almost 87% accuracy. So these are all the components that we have chosen for developing our project. So as I have told that there is an RGBD camera required for taking the pictures and the depth information. For that, we have chosen an Intel RealSense D435i camera. The whole manipulator and the gripper and the storage box will be present, mounted on a vehicle, and that vehicle will be moving inside that Apple field. For that vehicle, we have identified that Mahindra Jito will be our vehicle, and the back portion of the Mahindra Jito, all the things will be mounted. For the main part, the manipulator part, we have taken ABB IRB 1200 version. That is a 6 degrees of freedom manipulator, and it has a good precision. Now, to power up whole the process, we have chosen a 5 kVA generator because the manipulator itself requires quite lots of power. And for image processing and controlling all the things, or simultaneously working in various, simultaneously functioning in various systems, we have chosen Jetson AGX Ori, which is a higher version of Jetson TX2 board that previously we have seen. So it has the capability, means if you run the YellowV3 algorithm here, it only takes less than 1 second to detect our apples and localize them. So like that, I have said that we have using 6 degrees of freedom of manipulator. Now there are two things. As it's seen here, that R bar is the position of our gripper. R bar is our position of the gripper, and we have to find out where our gripper is. Now there are two techniques available here. One is forward kinematics and another one is inverse kinematics. So our manipulator base is fixed, but our gripper can move or go in any position. As this is 6 degrees of freedom manipulator, so this means there are 6 joints, but in this picture there are 4 joints are shown. But these 6 joints will have angle values, means for each and every angle of the joint, my gripper will go in different position. So if I know what is the joint angles are, then I can find out what is my position of the gripper with respect to base of my manipulator. So this is my base. So this is my base and this is my gripper. So if I know each and every joint angle, so then I can find out what is the position of my gripper, or rather what is the XYZ values are there for that gripper with respect to my base position, which is taken as 0, 0. So this is a 0th position and this is my gripper position. So finding out the gripper position by knowing the joint angles of our each and every joint is termed as forward kinematics. So forward kinematics will give us the gripper position when we know all the joint angles. Now, what we require? See, there are, suppose I have taken one picture and I have, this picture contains one apple. So by using the image processing techniques, we have found out where the apple is in the picture, and we have got the global coordinates. So that means where the apple is, that position should also be same as my gripper position. So that means by doing the image processing algorithm, whatever the XYZ values that we are getting for our apple will be same as my gripper angle. But to reach that position, what we need to do? We need to have the joint angles also. So I know the XYZ of my gripper, but what I don't know is the joint angles of my manipulator. So this is kind of inverse things. So this is termed as inverse kinematics, where from the gripper position we will be calculating the joint angles of our manipulator. Now in our lab we have bought one manipulator, 5 degrees of manipulator, 5 degrees of freedom manipulator, and we have done a forward kinematics. For what will the forward kinematics will give us the position of our gripper in XYZ in global coordinate. So what we have found out is that whatever, when we are using this forward kinematics by changing the angle of each and every joint, we have found out that this forward kinematics is giving us an accurate value. Means, first, suppose I have run it for the first time when all the theta values are 0, and I have calculated my gripper position, and then I have physically checked. Then we have physically checked the gripper position with respect to our global coordinates, and we have found out that okay, whatever the forward kinematics is showing the value XYZ, it is actually more close to our actual value. So now what we have done is that as our forward kinematics is giving us accurate values, what we have done is we have run a program and we have changed all these joint angles from 0 to 90 degree, and we have got huge amount of data for our gripper position. So that means theta 1 will be changing from 0 to 90, theta 2 0 to 90, theta 3 0 to 90, and again theta 4 0 to 90. So for these combinations, we have got lots of data of my gripper position for various joint angles. Then this is my data set creation part. Then after creating the data set, what we have done is that we have created a small neural network where the inputs will be my position like X, Y, Z, and my output will be the joint angles. Then we have trained it, and from there we have found out that the accuracy of the system is more or less 78% accurate. We have got using this small data set. So now what will be my whole structure will be, first the image will be captured, then the image will be processed in my main controller where ULV3 algorithm will be running. From ULV3 algorithm, we will be getting an identified and localized apples. So this apple picture means the pixel values, localized apple pixel values will be converted to global coordinates, and then these global coordinates will be fed to a multi-layer perceptron, where from there we will be getting our joint angles. So then this joint angle will be fed to our manipulator so that my gripper reaches the desired XYZ position. So this is the output of detected apples. So this blue lines is the bounding box which covers the identified apples. So this is the whole thing. So in this, this will be ULV3. So this is the output from ULV3 algorithm, and as you can see, there are lots of classes are present like red velox, branch covered red velox. So when we have taken the picture of the apples, then we have separated them in multiple classes like red velox, branch covered red velox, overlap red velox. Overlap means there are two apples are present. So then we have classified them as overlap reds for red velox. Then it is leaf covered red velox, means some of the portion of the leaf has covered that apple. Branch covered red velox, some of the branch might be covering the red apple. So like that we have classified them, and after classifying them we have trained them, and after training this is the output that we are getting. So this is the whole process. So first there will be an image will be taking, then there will be a convolution layer. After that pooling layer is used, then again convolution layer is being used, then after pooling, like that it will go. So this is our training progress. As you can see, for our training dataset or validation dataset, we have got almost 98% accuracy. Validation accuracy we have got almost 98%, and the losses are almost negligible. So this whole process has been done in MATLAB. This process has been done in GPU based computer, not in that Jetson Orin that we are going to use, but it is been done in our system, or rather say GPU based computer. Then whatever the weight files that has been generated, that weight file will be fed again to our Jetson Orin, so that this whole process remains intact and the ULOV3 can run in Jetson or in accurately. So this is the image that that we have got in running in Quadro P5000 GPU. This is a 1024 by 1024 pixel image. So again, in the Jetson TX2 in 256 by 256 pixel, we are getting very much good results. In this is a video image, not a still image. So we are getting almost 40 FPS. So 40 FPS is good, and you can we can see that it is almost detecting all the apples that are present there. So this is the movement of the manipulator will be. First it will grab the apple and then it will store it in the blue box. So this is the demonstration that we have done in our lab. So this is the camera that will be taking the picture of the apple, and then that picture will be then sent to our one of the laptops. So where all the ULOV3 algorithms and processing has been done, and it generated the global coordinates. The global coordinates and again then fed to this ABB manipulator, and that ABB manipulator is performing the gripping and storing action. So we are now currently in process of deploying all the things in the back of that vehicle, and in the June-August month we are planning to move our whole system to Kashmir and then starting our field trials. The gripper that we are seeing here is a pneumatic type gripper, and types of grippers and types of manipulator will be covered in the next part. So this is the third project that is going on in the CDAC Kolkata A section. So this is a tea harvester. So again, the tea industry also is facing some of the issues. What are the issues is that hand plucking of tea demands almost 60 to 70% of the worker deployment, and this is the most of the costliest operation in the tea garden. Now the labor cost is almost 60% of the total production cost, and when the manual labor is plucking the tea leaves, what it is doing is that instead of plucking the two leaves and one bud, it is plucking a bulk of teas. So that's how the quality of the tea is also decreasing. Now again, the skilled laborers are also moving from the rural to urban region for the better opportunities. So finding out a skilled labor is nowadays for the tea industries is a more tedious task. So to minimize these kind of problems, we are now in process of developing a selective tea plucker. What it will be do? It will be either it will be remote controlled or self-driven robotic platform. So again, it will have a multiple sensors and actuators. So here we are trying to develop an electro-hydraulic drive vehicle. So for the first phase, it will be completely remote control, self-driven hydraulic vehicle. Then after the second phase, we will be implementing this as an autonomous vehicle or remote control vehicle with an electro-hydraulic drive system. So it just not only will cut the tea leaves, but will also store it in some storage space. And after collecting sufficient amount of tea leaves, it will then dump them inside a specific location. Now to selectively pluck the two leaves and one bud, first we have to identify where is the two leaves and one bud. So again, here comes the image processing. We are developing an AI-based vision for identification and actuation, but also this will determine the location of the two leaves and one bud. So now what we have found is that hand picking is when it is hand picked, so one labor can pluck 20 kgs of raw leaves per day. But in case of machine plucking, where it is doing a bunch cutting, not a selective cutting, it can cut up to 500 kgs of raw leaves. But here, what is the problem is that in the bulk cutting, is that there are lots of leaves that is not in two leaves and one bud, or sometimes which are the old leaves are also getting cut. So these old leaves are reducing the quality of the tea. So now to enhance the quality, we have to choose selectively choose the two leaves and one bud that will increase the quality of the tea. And the mechanical plucking also reduce. We have seen that the average deviation of chemicals present in the cutted tea leaves are less than 1%. So we can safely say that instead of manually plucking the two leaves and bud, we can easily pluck two leaves and one bud. Not easily, but we can pluck two leaves and one bud using some kind of mechanical harvester. So we have planned to develop two kinds of vehicle. One is crawler type and another will be a wheel type. So both these vehicle will be hydraulics type, means there will be hydraulic drives present in there, hydraulic motors and everything will be present here. So this vehicle, all those two vehicle will have some kind of engine, pump, wheel, motor, and etc. Valve, battery, tank, storage, and electronics. So if you can see here for this crawler type vehicle, there is one arrangement present in front of the vehicle. Here, all the selective plucker arrangement will be present. The main job of this two vehicle will be to selectively cut two leaves and on a one bud, but also it can do the bulk cutting also. So as you can see, there are two storage units present behind of this crawler vehicle. One is to be used for selective for collecting the selectively cutted two leaves and bud, and another will be used for bulk cutted tea leaves. Both these storage unit can be used for the pruning purpose also. Pruning is nothing but cutting the little bit portion of the trees so that the new tea shoots come from that same position, the pruned positions. The smart tree harvester will have two objectives, as I have already told, for selective plucking, two leaves and one bud, and another will be to gross cutting from the top, which is nothing but a pruning. The machine that has been developed in Japan is doing the pruning thing, but it is not doing the selective cutting. Now, so for plucking head, what we require? First, for plucking, we need a cutter. Definitely, to pluck anything, we need a cutter. But where to pluck? That thing, now to pluck anything, first we have to see where the object is. Now, to see any object, what we need? We need a camera also. But not only camera, but with that, we also need to have some intelligent system that can analyze that image and that can sense our plucker that okay, here is the object is present and you need to cut it. So for that we need an intelligent controller also. If you see the technical component here, there are three main components are present. First is the identification of tea leaves. Second will be to localize the tea leaves, and third will be the cutting of tea leaves. Now, for identification of tea leaves, what we require is that we need a camera and we need an image processing technique artificial intelligence image processing technique. Now, for localization of tea leaves, what we required is that we have to localize our identified object in the captured image, and then from those localized bounding box, we have to convert those values into our global coordinate values. Then for tea cutting, we need an inverse kinetics, like I have already told, that it is to find out the gripper position. Means we know the gripper position, but we need to find out what were the joint angles required for the manipulator to move the gripper into the specific position. So this is the whole process. What will be the approach will be there. First, an image will be captured using the RGB-D camera. So here also, for calculating the global coordinates, we need an RGB depth camera. Then the captured image will be processed in AI-based image processing techniques. So where it will be located 2 leaves and a bird. Then we have to do the coordinate transformation, which is nothing but the localization of 2 leaves and 1 bird in our global reference frame. Then these global coordinates which are being generated will have to be fed to a plucker for the plucker movement. Then after reaching a certain position, our gripper has to cut the bird, 2 leaves and bird. And after cutting this 2 leaves and 1 bird, it has to be transferred to our storage unit effectively, such that the 2 leaves and 1 will not get damaged. Otherwise, it will lower the quality of the tea. Now, this is the diagram of the YOLO V3 algorithm. So developing any image processing, artificial intelligence based image processing algorithm, what we required is that we required a lot of data. So for generating a data, what we have done is that we have developed an image capturing unit. So as you can see here, this is our main camera present. So this is our main camera. So here all the electronics and batteries are present. So this is a one power bank, that is power bank, and these are the batteries that has been used to power our main controller board. So we have placed this image capturing unit inside the tea field, and we have collected more than 1,000 images, that too in different lighting conditions. After capturing these images, what we have done is that we have labeled it. How we have labeled it? Suppose we have taken one picture, and by manually verifying the image, we have seen that okay, there is a 2 leaves and a bird. So we have created a rectangle box, and we have put that rectangle box around the manually seen 2 leaves and a bird. We have done it for all the 1,000 images, and we have created an yellow we have created an image dataset in .xml format. So this is a specific format that we are using for training. Then there is a one model, YOLO V3 model are there. So this model requires two things. One is the configuration file, where it has written all the YOLO architecture, like what should be the convolution layer, how many convolution layers should be there, what is the size of the convolution layer, is there any padding is there, if it is a padding is there, whether it should be 0 padding or 1 padding, like that. It is all written inside this configuration file. Now this YOLO architecture is being developed for COCO dataset. So these convolution layers and everything are already pre-trained. So if we use the pre-trained convolution weights while training our model in our own dataset, it will speed up the process. So for that, we need the pre-trained convolution weight, which is already easily available. So now after generating this configuration file, and providing this pre-trained convolution model, we have trained our model for our own dataset. Now there is another thing present in this yellow algorithm. These bounding boxes which are being generated after training this model, they are based on the anchor box which is being defined in this configuration file. So rather I can say is that whatever the anchor box values present in the configuration file, that is more or less affecting my bounding boxes. And as I've already told you that this model is primarily designed for this COCO dataset. So all the anchor box that has been present in this configuration file are also optimized for COCO dataset. Now to configure this anchor box for our own dataset, what we have done is that we have used k-means clustering algorithm with what the bounding boxes that we have been generated in this image dataset. We have fed all those data in our k-means algorithm and we have generated anchor boxes. So these anchor boxes are specific to our own image dataset. That is not this is not specific to COCO dataset. So using these two modification, we have trained our yellow V3 algorithm and we have generated an weight file. So this whole process has been done in one GPU computing GPU system, Windows-based GPU system. Now, when this weight file has been generated, what we can do is that we can transfer this weight file, this configuration file, into our main controller, whether it will be Jetson TX2 or Jetson Ori, and within this system we can run now our yellow V3 algorithm. Primarily what we have done is that we have trained our model in our Windows based systems, and when we are testing our algorithm, we have doing it in our Linux based Jetson Ori or Jetson TX2 system. Now, as we can see, is that here these green boxes that is labeled by us means here we are saying that okay, this green bounding box contains the 2 leaves and a bud. Okay. Now also while labeling it, we have defined two classes. One is T-bud side and one is T-bud top, because all the tea leaves that are that is being here, there are all not straightly up. There will be some kind of tea leaves that is in a sideways position. So we have defined two classes. One is T-bud side and T-bud top. T-bud top, to distinguish between these two types of tea leaves. So total 1200 images are captured, and inside these things we have used 532 images for training and 120 for validation during this training purpose. And this model has been trained up to 200 iterations. Now after that, what we have got almost 92% accurate model. So this is the output from the yellow V3 algorithm. It is detecting all the tea leaves that has been present inside a captured image. And what is the middle dot is that it is the middle point of the bounding boxes. So this is the performance comparison. So as I've already told that we have trained it in a Windows-based GPU system, and we have transferred this weight file into our Jetson Orange system also. Now there are two kind of language that has been used. When it is been trained in the Windows system, one that has been used by Python and using the TensorFlow libraries. But when it is being tested on the Jetson Orin, it has been tested in both the scenario, means using the Python and both in C language also. So as you can see, when we are testing it using this Python and TensorFlow library in our uh, Windows system, it took 13 seconds to process one image. Okay, and when the same image is being tested in Jetson or in with same Python and TensorFlow algorithm, it is taking 7 seconds. So that is a massive jump in performance. But when the same thing, or rather, it has been shown here is that it is that V3 algorithm within the COCO dataset, we have got 1.21 second in C language. So that means we can safely say that C language, if you use the C language for our AI-based image processing techniques, so it is much more faster. So if you imagine, suppose my system is taking 7 seconds to identify and localize our two leaves and one bird, and then after localizing it, it is converting the global coordinates and sending it to a plucker, and then plucker is moving towards the position and cut it. So that means that will take a huge amount of time. So if you compare it with our manual, someone plucking a tea leaves, and our developed system is doing the same thing, you can see that huge amount of difference if we use Python as our main language. But if you use the C language, so it will almost instantly can identify the two leaves and a bird, and then it can send the plucker the coordinates, and then plucker can do all these operations. So in using the C, when our developed system is using the C language for processing, then the performance of our system can be comparable with any human doing the same thing. So in this process, whatever we have seen is that C will be the main language for developing any kind of AI-based image processing techniques, whether when you require a good amount of performance. If performance is not the main issue, then Python can be easily used. Suppose we are developing a system that will be running in cloud computing. So then we can safely use the Python, whether then the performance means the speed of the performance is not an issue. We can definitely can means have some delays of doing the calculations, but when it requires a real field application, C will be the best choice. So we have developed an plucking mechanism. This is the first prototype of the plucking mechanism. As we can see here is the whole frame structure. There are some lead screws on there, and for each and every axis, so that means there are three movements of their axis movement: X, Y, and Z. So on each and every axis, there is a stepper motor has been used. This stepper motor will guide the gripper to an appropriate position. The gripper that has been shown here, white and green one, it's a little bit bigger because it's the first prototype. We are now in our process of developing another version of it. But instead of using this lead screw, we will be using a belt-driven system like the 3D printer that has whatever the 3D printer is using, like the same mechanism will be used for developing a second version of this. And instead of this stepper motors, we'll be using on servo motors, which will be much more faster and accurate. This lab level prototype can cut 1 leaves in 1 minute, but we are trying to increase the speed here. We are estimating that that improved version of this selective plucker can cut 5 leaves in 1 minute. The main drawback of this design is that the lead screws are not so efficient, and there are some kind of sagging is there in the main lead screw, y-axis lead screw. That's why we have to reduce the speed, and that is. So thank you. So any more questions? Other
Thanks, Shomik. It's a very engrossing session, and you have explained a lot in how the agriculture, in the agricultural field, in the real level, we can really use robotic applications for the betterment of the society. Now, we have seen so far in your lecture that there are the 3 challenges in the present agriculture section, like in the population explosion, and you must be knowing that we are having the highest across the globe. We are having climatic change, which is completely abnormal and which is leading to increase in the greenhouse gases and ozone layer depletion, and which, because of the heat waves, we are getting flood, which is reducing 50% of the yield. And there is a problem that the young people, they are not getting or not coming to the farming, and the farmers' income is getting reduced. So to have these things, what you have developed robotics in the field, or in the field of agricultural robot, which is autonomous field robot for the paddy cultivation. And it's basically, if we see that, it is an autonomous field robot for the paddy cultivation, where the no intervention for the people, and it is because of the scarcity of land and manpower. And also you are doing the seeding here, and there also you are doing the crop scouting using the seedling count, the chlorophyll index, the growth monitoring, tillering monitoring, disease detection, all such stuffs you are doing. And also, this equipment is completely suitable for Indian environment. You are also doing the spraying of the weedicide and the pesticide. So excepting harvesting for which the other appliances are there. So you are doing the remaining part. And as per ICR, the rate has been found it is better. Application of AI, computer vision, laser range finder to find the distance between seeds and germinations had made it more effective in the field. Now, there are the certain kind of challenges like the ground clearance. You are doing the precise navigation, which is of the 20 to 30 centimeter width is there, and you are having the heading accuracy. Real-time decision making and actuation, which is the basic most important part, because you have to do the sensing, then you have to go to the controller section, you have to have the decision has to be done, and then the actuation has to be done on the field, and it has to be done all the things in the real time. You are having the muddy water field farmlands, but you are trying to develop it in the next versions, and it will be operating for 3 to 4 hours at a stretch because of the battery capacity, and then it will be going for the recharge. You are also doing the plant health monitoring for precise spraying, and because for this you are utilizing the GPU-based main control board for the high performance computing, which is required for the real-time sensing and actuations. And these nodes, whatever the nodes you are having inside that is operating in the publish and subscribe method. That means all the sensors are publishing the data, and then the users from the other end, you are pulling the data, you are subscribing. The second application is very interesting, which is the apple harvester, which is deployed in Kashmir due to the scarcity of the labor as well as the high cost of the labor. Here, the vision-guided robotic apple harvester you are utilizing with the features that the human-driven or the remote control vehicle is there. Second is the robotic arm with the manipulator and gripper is there. AI-enabled image processing for apple identification and localization. And there is a four-wheeled hybrid power-driven vehicle. Now, the methodology is comprising of the fruit detection, then the maturity detection, localization, approach to the target, detachment, and placement in a storage kit, and then you are moving to the next fruit. So this will be operating in a loop. There is a 6 degrees of the freedom in the manipulator, and the forward kinematics gives the gripper position, and you are having the change in the theta values, which is basically the joint angles from 0 to 90 degree, which is getting stored in a database, and which is basically training the neural network, and which is giving you approximately the 78% accuracy. Now, this uses the convolution neural networking and the yellow V3, which is the you only look once, where the bounding boxes will be there. You will be taking the middle point to spot finding the thing. Third application, which is a very interesting application, tea harvesting in the Darjeeling and Assam and all the areas, which can be deployed elsewhere also. We are having the issues of hand plucking of tea demand to 60 to 70% of the worker deployment. Next problem is that labor cost is around 65% of the total production cost. And third is a very prominent problem that the skilled laborers are now moving out for the better opportunity. The solution is the smart tea harvester. The hand plucking is per day efficiency is 20 kg of raw leaves, where the machine plucking will be 500 kg of raw leaves per day. Objectives will be selective plucking. 2 leaves and 1 bud needs to be taken, and there will be gross cutting from the crop, which will be basically pruning, so that the next type of leaves will be cutting from the pruned areas. Here, there will be the 3-part activities: the tea leaves identification, tea leaves localization, and tea leaves cutting. Here, the high performance algorithms will be utilizing. There will be AI analytics, and there will be convolution neural networking, which will be utilized over here. Yellow V3 algorithms will be utilized so as to pinpoint the center point. Here, the plucking head will be having a camera, which will be AI-based image analysis, and plucker and cutter will be there, which will be utilizing the inverse kinematics. The model will be trained with the 1200 images will be captured, 532 images will be utilized for training, and 120 will be utilized for validation, and 200 iterations will be done. With this, you can utilize Python, you can utilize TensorFlow, as well as the C languages. TensorFlow, it is utilized because the images which will be coming, that will be having the RGB, that is the red, green, blue. So there will be 3 levels. So it cannot be the matrix, it will be the 3 dimension, which will be the tensor. And that's why the more efficient algorithm in the TensorFlow is utilized in the convolution neural networking. Now, it has been seen on the practical deployment that the C language is working faster in Python, and which gives very fast operations, which will be better than the manual or at par with the manual. So these applications of artificial intelligence will be completely giving the precision farming, because in our country, the major problem is the water is getting wasted. There is pesticides are getting wasted. So the precision algorithm, if you can utilize, that will be giving the higher yield, and it will be the cost will be getting reduced, which will be beneficial for the human being. Now, with these things, I really extend my thanks, sincere thanks to our today panel speakers, Dr. Hena Rai and Mr. Somik Laik, who have actually deployed the machines, which is not the theory, it is the machines which have been deployed, which can be, and it is the basically Make in India concept, and which can be deployed in the real field operations, which will be giving us a complete boost in our country. Now, we got the 2 questions at this moment. First one is Dr. Subhash Chandra Saha was asked, what is the present cost of the machine? Somik.
So which machine, sir?
This, I think Dr. Shah is referring for your paddy field operations.
Okay.
Your autonomous field robot for paddy cultivation.
So in this paddy field, robot may not, we have not estimated anything, but it is been thought of that whether if it is a high cost, if it is a high cost machine, it has been thought that it can be given to farmers as an base of service type. Means if some farmers are required, then they can take it for 2-3 hours and they can be charged accordingly that.
Okay, you are talking about that it will be on the rental basis, right?
On the rental basis.
Second part, I think that whatever you are talking that at this moment it is working in the dry area, and you are also innovating it to the next level that it can be utilized in the muddy lands and all, right? So
Yes.
we need to find out the cost of the machine in the muddy areas, and when that mud operations it can work autonomously and it can give the truly the actual movement in terms of the controlled spraying, in terms of autonomous navigation, in terms of the holonomic drive, in terms of communications, direct sowing of seeds, plant health, and unique robotic vehicles, which will be giving the multi-power activity in the single vehicle. I think the cost should be at par as in that, so that the overall cost, which should not be the overloading the user requirement, right?
Definitely, sir.
Right. Second is that with the same machine, Dr. Subhash Chandra Saha has asked another question. What's the minimum area of land for operations?
Minimum area of land.
Yeah.
So as this robot can move, see this robot can move as long as this battery are charged. Okay. So if then the robot is moving in human like speed. So it has not been estimated accurately, but as long as the battery can be capable of providing the enough power to our battery, so it can definitely cover the whole field. But
Absolutely. Actually, your battery is operating for the 3 to 4 hours at a stretch operations, right? Now, here the question comes, that will be the maximum area at a stretch which can be covered. The minimum area he wants to talk. Nowadays, what is happening? The farmers, the land is getting reduced and reduced because of their own whenever he is having more number of sons and others, so that their property is getting distributed and the land areas are getting reduced and reduced. So suppose a farmer wants to utilize, he is having a very small area. So how much what should be the minimum area of land where this can be effectively operated? I think Dr. Shah must be meaning that.
We have not estimated that much.
Yeah.
The in that video, there's some land is being shown, right? So that it can cover that whole area.
Okay. Shomik, another thing is just we are in India, we are having enough sunlight, right?
Yes.
So can we explore for the solar power?
Yeah, solar power. Sir, actually, basically what happens is that the power required for this kind of vehicle to move is a little bit higher. And if you want to use this solar power, we can use solar power, but not to drive it directly. Means we can use the solar power to charge the battery.
Somik, in our country, the world's first, the airport at Trichy is completely operated by the solar power, which is 50 megawatt power plant is there.
Yeah,
and which is operating the entire airport, everything, not a single power connection is there. So you can explore, it can be utilized. So you can have a higher area of operations and higher duration.
No, but in that case, the size of the machine has to be increased, no? Because the battery size is that 80 ampere hour battery is being used.
Okay.
So if it is working for 4 hours, so that means 20 ampere is required per hour.
Okay.
that amount of power requirement means that we need a lot of area covered in the solar panels. So if
you can think of that, whether that solar panel can be fit onto the machine itself. You can just think of, right?
It can fit, but it may not provide whole power to the battery, but it can somehow provide the charging power to our battery so that the battery can last little bit longer, like 4 hours to 6 hours. It can
and the cost of production also will be less. So you do not have to depend on any type of electrical power for the recharging and others. So you do not have to find out any recharge station. It will be self kind of.
Yes. We can use solar panel. We can build one solar panel based charger. So when the battery is almost died, so we can use that charging to charge our whole battery. Solar power charger to charge our whole battery.
Yeah. So you can go for the higher recycling operations, like nowadays the batteries which will be utilizing 80 ampere hour. It can be lithium ion based batteries as well.
Yes.
And nowadays the batteries are coming from Sweden and others. It is coming for the 6,000 cycles or something like that, which operates for the long time. You can think of all such things which can be improvised in our country, country specific areas, right?
Yes.
Anyway, we got several other these two questions, and now it is open to the floor. If anybody wants to ask any question, Mr. Ashish Das has raised his hand. Mr. Das, can you explain your question? Mr. Ashish Das? Yeah, you can unmute and you can ask the question.
Okay, am I audible?
Yes, you are audible.
Okay, sir. Thank you, sir. So I have a small question that you are telling that Mr. Laik is telling that we can spray the weedicide or pesticide for individual plant wise. So the same fertigation or fertilizer can be sprayed in that way for different stages of this plant.
Different
stages of this means the paddy that particular plant. That means it is in 20th day we need some fertigation. So is it possible in 22nd day we need another fertigation? Is it possible? That I'm asking. Fertilizer spray, something like that.
So the developed machine that we have developed is that the ground clearance. The main issue will be here will be the ground clearance.
Yeah.
If in the 20th stage, if the plant height is more than the ground clearance, so there will be some kind of issue. But if it's not that case, then we can we can up the spraying mechanism a little bit higher, and then we can spray the pesticide fertilizer.
Okay. And is it now this particular robot is for only paddy, no?
No, this is our only paddy field.
Because myself from Agriculture University, it is Uttar Banga Krishi Vishwavidyalaya. I think you have learned about this university. This is a state agriculture university. So I am the associate professor of that university. I am basically not from the agriculture background. I am from electrical engineering background, and I am associated with agricultural engineering department. So that's why I have asked the question. Thank you, sir.
Somik, what he's asking is, what Dr. Das is asking is that he's thinking whether this can be redeployed based on its own customization and others in the other fields, like he's maybe thinking of the wheat or any other plantations.
Exactly, or maybe maize, jute,
jutes, other things, right? So I think Somik, they must be doing this for the paddy, and later on they must be thinking of the innovating this machine for the other particular fields like maize, wheat, or any other thing, jute or any kind of thing, which are basically the cash crops in our country.
Yeah.
Which can be utilized. Any others?
Wheat can be. This means this vehicle has been designed based on the field presented to us. means the spacing of rows and everything that has been predefined, and based on that we have designed this robot. But in case of wheat, if we can build such kind of field that matches our design criteria, then definitely this machine can also be used in the other crops also.
Yeah, Shomik, what he was asking also is that every individual, the crops are having the different, the gaps between their own germinations, between the saplings, right? So the machines can be redesigned based on that particular. So some different machines can be designed for the different particular applications. It can be thought of, right? And it can be jointly worked with Dr. Das. He can also guide for the necessary spacings and others, right? For a particular, I think joint collaborations can be done. That's so co-creation can be done, right, Shomik?
Yes, definitely.
Yes, yes, very good.
Chanchol, I have a question.
Yes, yes, please.
I was thinking if for navigation, we can use drone, because nowadays drone is also very popular. If you can reduce the function on the ground with this machine and helping with navigation and other things from the drone, camera and other parts, size can be reduced, and I don't know, maybe function can be divided into drone and the ground system.
Yes, Ramda, I'll tell you this suggestion is well taken. And CDAC has already developed this type of drone-based machines for the water sprinkling, the pesticide sprinkling, and everything. Only this drone cannot do the sapling, but other things can be done. The drone has been deployed for the precision farming, and those things have already been discussed in other lecture by Dr. Navarun Bhattacharya some time back. And you are right that the photographs and other things, based on this convolution neural networking, it can be analyzed, and then accordingly actuations are getting done. That is a part of precision farming, and that is based on the particular grid of the areas, and actual amount of water will be sprinkled, actual amount of pesticides will be sprinkled, so that the water wastage, which is a common in a country, 70% of the way water is getting wasted, or the pesticides are not also required unnecessarily. Those pesticides are unnecessarily increasing the cost of the crops, as well as those pesticides are utilized, goes as a chemical waste to the water bodies, which is further deteriorating the environment. Those things can be prevented, and the precision farming, they have developed this type of products. I think we can discuss again in some other session with those their expertise. Now, Mr. Avirup has asked a question, sir, can we just use the solar panel in the device instead of the batteries, because the machines are used in the daytime and the sunlights are sufficient for the solar panel? I think, Mr. we discussed this issue, and they are utilizing 80 ampere hour batteries, and they also will re-explore this idea of using the solar panel, whether it can be deployed. We have already discussed, right? And they will be taking as an input for the research activity. I think, Soumik, that is the thing you are getting the input, right?
Yes, sir.
Yes. Yes. Any other person? Any other person wants to ask any question? If there is no other question, Ramda, I think the vote of thanks can be extended. Over to Ramda. Hello, Mr. Ramchandra Chakraborty.
I think this is the formal duty of our Honorary Secretary, West Bengal State Center, Professor Raju Bashak, to propose vote of thanks. I think he's not there, so I take this responsibility on my shoulder. On behalf of our Honorary Secretary, I extend thanks to all the participants, all the panelists, and the moderator, and our dear Sudeep to facilitate this webinar. And we look forward to have you on the next monthly seminar. Meanwhile, I also want to give you a small head start. We shall be celebrating World Telecommunication and Information Society Day 2023 on the theme Empowering the Least Developed Countries through Information and Communication Technologies. on Wednesday, 17th of May, between 6 to 8 p.m. at our Arun Mukherjee Hall, Institute of Engineers, Kolkata. So I request all of you to be present physically there, and we'll announce shortly about our webinar for the month of May. Thank you very much once again for your continued support and patronage to our webinars, and wish you a pleasant evening. Thank you so much.
Thanks, Ramda. Thanks to our today's panelists and Mr. Sudhir Chakraborty, whose continuous support is there. Without his support, we cannot organize this type of seminars. Thanks to our chairman, thanks to our honorary secretary, and thanks to all the beautiful audience today who has made our this evening really pleasure. I think a lot of interactions has happened with this thing, and this has enriched us also. Panelists also got their input, which they can take it for the further research activities. So with these things, we conclude it here, and we wish you a very good evening. Shubha Akshay Tritiya and Eid al-Fitr. Thank you very much.
Thank you, sir.
Thank you all.
Thanks all.
Sudhir, you may please close the session.
Okay,
Thank
sir.
you, Sudhir. Thank you very much.
Okay, sir. I'm ending the webinar with thanks to all.
Okay, have a nice evening, Sudhir.
Okay, thank you. Thank you, Sudhir.
Thank you.